So hello everyone, welcome back to our channel. And today we will be completing. Firstly, we will be completing our previous question and then move to our next question. So our previous question was largest rectangle in the histogram. So we have discussed the brute force and the optimal one, but the optimal one was not too accurate to tell. So I have learned that concept again, and here I am with you guys to explain it further. So let's take an example where we have a array and we have given the array of 3, 2, 10, 11, 5, 10, 6 and 3. So these are basically the height of our histogram graph of every index, and index will be their width and it will be always be 1. So our task is to get the largest rectangles that can be possible to made by these all graphs. By combining them, making different combinations, we will try that. So for the optimal approach, what we can do in our brute force, we have analyzed that we need the previous smaller element and the next smaller element, and by which we will be calculating the maximum length that can be possible to make the rectangle. And for that we have used the concept of PSE and NSE in our question. But what do we actually need? So we actually we need to analyze the next smaller element and the previous smaller element along with the traversal. We does not require any other function or extra space. So for the optimization, firstly we will be calculating our previous smaller element while traversing, and along with the traversal our task is also to calculate the next smaller element. So with the basic traversal, we will be able to calculate the previous smaller element. But with that, we will not be able to calculate our next smaller element because we have not traversed yet to the end, and so that we cannot tell which one element will be our next smaller element. So firstly, we have to traverse up to that element, and then we have to analyze their maximum area. So this will be the code strategy, and for this suppose for the 3, that's our first element, we are taking an stack, and in our stack we will be putting the index values so that we can analyze the total length that we require, because height is already given to us in the form of array. And our main target is to calculate its overall length that can be possible, and that height cross length will be the area that is possible by a single graph. So our task is to calculate the length. So for calculating the length, firstly analyze, like we will be putting all the index of every array graph in our stack, and to understanding better we will just put or hypothetically put the values to compare to analyze it. But we will actually we will be putting only index in our stack, so we will tell it in our further code. So firstly for the 3, our previous element is not given, so our previous smaller element will be -1, and up to we does not reach to our next smaller element, we will continue our traversal. So for 3 we will just put in our stack, index 0 will be put in our stack, and goes to next index. Next index is 1 where value is 2, so that is completely the previous next smaller value. After 3, 2 is the smaller value. So for 2, first we will pop it out 3. So basically we are calculating the next previous smaller element for our next element. So for 2, because 3 is not the previous smaller element, so we will pop it out, and at the time of pop it out, firstly we will calculate the max area possible, because for 3, 2 must be the next smaller element, that's why 3 is popping out. So this is the core concept. So for 3 we have understand that our next smaller element is 2 and previous is -1, and after calculating the area we will get max area as 3. And what will be the our max area formula? So our max area formula was array of I multiplied by NAC minus PAC minus 1. So that's how we will able to calculate our maximum area. And for 3, our max area is 3 because 3 is the height, that is array of I multiplied by NAC. So next smaller element is at index 1, that is 1, and minus 1, that is our previous smaller element. So overall it comes to 3. So that's how we calculate for 3. And now we can put a 2's index, that is 1, in our array, in our stack. So we put the stack array index 1 in our stack and move forward, and after moving forward we got the 10 as our value. So for 10, does not we have the previous smaller element as 1 as 2, so we will just move forward. And for 11 we got the 10 as our next smaller element, and we will just push back all index until we does not reach up to any condition where their top element, stack's top element is not the their next previous smaller element. If it is not, then simply put, if that condition arises, only that we will pop it out. So for 11 we will just put them all index, and after that 5. So for 5, our previous element or our stack's top element is not the previous smaller element. So in this case we does not have our previous smaller element, so we will firstly pop it out 11, and at the time of pop it out of 11 we know that next smaller element is 5. So index of 5 is our next smaller element index, and previous smaller index is 10 because it is setting while we are traversing. And so maximum area that 11 can cover is on array of I, that is 11, minus previous index, that is the next index, that is 4, minus previous index, that is 2. So 4 minus 2 minus 1, that is 1, multiplied by 11 is 11. So maximum area that 11 give is 11. Now moving forward, we will put the 5 index in our stack and move forward and calculate for the 10, that is our next element. So for 10, our previous element is set 5, so we will just push back it and move to next element, that is 6. For 6, we will firstly pop out 10 and check maximum area for 10, and then move for next and putting 6 index in our stack. And this is how we will overall calculating all the values. So that was the intuition behind my approach. For the pseudocode for this question, we will taking a stack and a maximum area is 0. Firstly, we will be traversing from 0 to n minus 1 in our loop and check our previous smaller element condition. So there are two conditions. The first condition is we will check for previous element. So for that, our stack should not be empty and array of stack's top element should be greater than array of I. If it is greater than array of I, that's the condition where our stack's top element will be calculated. Means we have get our element for which we will calculate our further area. So that's known as element, and element is equals to stack's top. And now we have understand for whom we have to calculate maximum area. We have our next smaller element, we have our previous smaller element, so we will pop it out, and our next smaller element will be what? Our current index is our next smaller element index. And what is previous? So for previous we will check if no value encounters -1. If any value encountered, that is our stack's top element. It means first index dot top element will be popped out, and after that we are calculating the stack dot top element. So we have to remind it, and that's how we will have our previous smaller element and next smaller element. We will calculate our area, and that will be our array of I, means array of element multiplied by NAC minus PAC minus 1. So that's how we will calculate that area, and then we will push down our last index element or index, that is stack dot push, and there is another condition. Suppose after all the traversal there must be some element that do not encounter, means we have not checked for them, so we have to check for them also. So for them, our next smaller element will be hypothetically n, and previous smaller element will be -1 if any element does not encounter. So we will check for the our first element of our stack, means stack's top element will be as our element, and we will be calculating area for that only firstly. And stack dot pop out, and our previous smaller element, we will check the condition if our stack is empty, then -1. If it is not, then stack's top element will be our next is previous smaller element, and applying the formula we will get our maximum area. And we will be comparing the maxi comma maximum area, and that's how we will able to calculate our maximum possible rectangle. And this is the pseudocode of our largest rectangle in histogram, and we will be using this concept in our next question. That is nothing, just maximum rectangle. Maximum rectangle is a question of a 2D matrix question. So I will tell you what the question says. We have given a matrix of n cross m, in which we have element as 1 and 0. We have basically two elements, either 1 or 0 in our box of every index. So our task is to return the maximum rectangle that has only 1 in it, means maximum area or maximum area of rectangle that has 1. We have to return that area. So for this I will paste a questions pseudocode and a questions photo to tell you what questions is and what my approach is. So our question says that we have to calculate the area for the maximum number of one that encounters together. So this is our target. So how do we can do that? So suppose we have given a 2 cross 2 we have given a n cross m matrix, and it is pasted in the side screen as you can see in it. So in this we have given a 1 0 1 0 1 and this type of matrix, and we have to calculate for every matrix maximum area. So we will be traversing from one row to another row and checking the maximum possible area. So as you can see in the brown color, first our element is shown, and in the first figure, we have shown that uh, in our first figure we have shown that there is a single line of one element, and that is the area of a rectangle. So its height is 1 and its width is 5. So 1 cross 5 is 5. And along with that you can also see another element from second and third row. 6 elements are together, and with them their area is 2 cross 3, that is 6. That will be the maximum area for this question. And that's how we will able to calculate. So what strategy we should apply? So previously we have learned the histogram concept, where we are calculating the maximum area by using histogram. So we will be applying that in our this question. So our target is firstly for check for the first row. If you see first row, only just assume that there is a single row given, that is 1 0 1 0 1. 0 will nothing, and 1 is our histogram bar graph. And with this concept you can analyze it, that 1 1 1 there are 3 1, and the maximum area will be 1 cross 1, that is 1. So for first row it is clear. And now if we add two rows, means we are now checking for two rows, that is given in our pink color question, that is second figure. We can clearly see that there are three 1 comma 1 height element, and there is a 1 element, and we can see the area, maximum area that can be covered with them. So by adding two rows we are checking, and the histogram bar graph is continuing ourselves. Now comes to the next part, that is the third part, when we are including three rows in itself. So in case of three rows we are able to see that there is a histogram with 3 is the maximum height that I can see, and for maximum width 1 2 3 4 5 5 will be the maximum width. that can be possible, but we cannot make the a rectangle for them. So what we have tried is 1 cross 5, 3 cross 2, and now as in our previous question, we are just putting these histograms in our previous question concept. So we will making a function of our largest rectangle histogram, and we are putting these values in our that question by making a array. So how we can do, I will further tell it, but just analyze. So I thought you can understand what I am trying to say. I am just trying to say we will be continuing and checking for every row. We will be moving row wise and adding the values column wise. So for the last second figure, that is the green value, we can see that there is a 4 cross 4 matrix where we are taking the 4 height as our maximum height, and we are calculating the area. And when any zero encounter, we are not checking for that value. We are just checking for those value which have 1 in it in their x-axis lower side. So how we can do it? So we can do it by using the prefix sum concept. So earlier we have discussed what is prefix sum. Let me tell you. So in prefix sum, we traverse from 0 to n minus 1 and just add the values for every row. And after adding for every row, we take sum as 0. So that's how we will able to calculate for every rows their own prefix sum. And we can do similarly for our column that we are doing in this question. We are adding for every row in every column. So that's how we will able to do. And in this question, the last figure shows our matrix, that is our prefix sum matrix. So in our prefix sum matrix, you can see that 1 0 1 0 1 is for first row, that is obviously same as it is. For our second row, our 1 comma 0 and 2 comma 0 element add together and gave our sum as 2. So 2 0 2 1 2, that is our second row, and we have nothing, just add our column wise adding elements. And for the second row it is 2 and 0 2 1 2. So that's how we will continue our adding. We will continue our addition for each and every row, and wherever 0 encounters, we will do our summation as 0. So for the third row is 3 1 3 2 3, and for the fourth row 4 0 0 3 2. So for every row we have understand the height that we are showing in our graphs. So we have understand the maximum height that can be possible for each block in our every row. Now we have every, in a single row we have the maximum height that is given in our previous question. We have that maximum height, and with the help of our previous question code, we will able to understand and we will able to implement our maximum area, and eventually returning the maximum area, and take a maxi as our comparison operator, and we will compare maxi from maximum area of our histogram and return whichever will be the maximum. So that's the strategy. So coming up on the pseudocode. So for the prefix sum pseudocode, we will taking a matrix, and for the function matrix, we will taking a 2 cross 2 matrix where maximum area will be as 0 as initialized, and our prefix sum will be calculated. So for the prefix sum, we will moving from 0 to m minus 1. N cross m is the matrix, and we are moving in m direction, means we are adding elements in a column direction. That's why we are moving from 0 to m minus 1 in our first loop, and sum is at 0, and again traversing from 0 to n minus 1 and adding the elements that I have told earlier what is prefix sum, and adding the elements and just checking another case that I have told earlier. If our matrix of ij is 0, means whenever the 0 encounters, just make sum is equal to 0, because in a case like 1 1 1 0, so for the fourth row, that 3 1 will be not counted, they will be counted at 0. That's why we are making sum as 0 for the fourth row itself. So we have to do this condition, and in the end our prefix sum ij is equals to that sum value. And after getting the sum value, as prefix sum, we will take another loop from 0 to n minus 1, where maximum area will be the max of our maximum area, comma our largest histogram questions function, and in that function we will be passing our prefix sum array, and in the end we will be returning maximum area. So coming upon the time complexity, for the time complexity it is 0 big O of m cross n for our matrix collision or making the prefix sum, and big O of n cross 2m for our calculating maximum area, that is 2m will be for the maximum largest histogram question area, and big O of n for the traversal. So that's how our total complexity is big O of m cross n plus big O of n cross 2m. And for the space complexity, it is big O of n cross m and big O of n. So overall, we are able to solve the both question in a much more efficient way. And I hope you understand the concept. I will be adding that graph in our question, and with this, our today's concept ends here, and we will be continue our journey. And as talked earlier, we will able to complete Stack and Cube playlist by end of November. And with this, today's video ends here. Thank you. Have a nice day.